How's it going? Time for another daily coding problem. Today's problem comes from dailycodingproblem.com. I got the email today. So let's see what we have in store for today. Have up to an hour to work on this. Gonna start my stopwatch now. Here's what we got. This is what came in the email. This question was asked by Amazon. Given an integer k and a string s, find the length of the longest substring that contains at most k distinct characters. For example, given s equals a, b, c, b, a, and k equals 2, the longest substring with k distinct characters is bcb. Right in the middle there. bcb. Okay. So, this makes sense, right? Makes sense to me. I don't see anything crazy in here. We're probably going to want to come up with more test cases than this, just to make sure that our stuff works. Yeah, so let's get started as normal. I'm just going to take what they've given us here and put it in an actual test, and then we can start thinking about how to make this work. So we'll do solution test. We're going to use mini test for this. And of course, we want color in our output. We want it to say fabulous. So we're going to add mini test pride. Require relative. And then let's describe what we want our solution to look like. Forgot my do. This is going to be longest substring, I guess. Is what we can call our method. It returns the longest substring with k unique characters. Okay, spell check. Okay, looks good. All right. Let's grab what we've been given in our test file here, in our README. We'll snag this. Okay. So we've got s equal to this. Very good. We've got k equal to this. Good. And we expect to get back a result of that. Assert equal this thing and the longest substring of this with that many unique characters. Okay, let's run this just to get our other file set up. So it can't find our solution.rb, so we'll create that. Class is solution. This is going to tell us we're missing our method. Yep. Undefined method. Longest substring. Longest substring. And this takes an S and a K. Okay, now we have a real failure. So what do we want to do? I'm going to bring our test open again on this other side. How to solve this? What I think we want to do, there's a whole class of problems that I've been seeing as I'm doing these. This is day number 15 or something that I've been doing these problems. And I've seen a pattern like this before. And a lot of these interview questions, they seem to fall in like one of a handful of buckets of problems. So if you can just figure out what bucket it's in, you know, is it a tree? Is it a substring? Those are the two big ones. For so many questions involve trees or substrings. And oftentimes with substrings, your goal is to find some substring that satisfies some criteria. And then in order to get the answer, in order to find that substring, there's a few different ways to do it. One involves like exponential time, where you just keep scanning over and over and over again, trying to find what you're looking for. But the other solution is this technique that's called like a sliding window, where, for example, I'm going to grab this string that we're given and show you what that looks like if we do a sliding window. So let's paste it in down here. Okay. So this is our input, right? What I'm thinking we do is we have a start point and an end point, and both of those start at 0. So if I can illustrate this, I'm not really sure how. Let me do I and O. So let's do S and E. S for start, E for end, maybe? Okay, so imagine these are pointers, right? And maybe I can even add some indexes up here. 0, 1, 2, 3, 4. So both our start and our end start at 0. And then we just keep moving our start till we get to the end of the string. So our first step would be to go like this, boop. So we move our start to position 1, and now we have this substring, and we'll keep track of the number of unique characters we have. So right now we have 2 unique characters. So we'll take this substring and save this as our new longest substring with 2 characters. Then we'll take our start. Oh, whoops, I should be moving the end, shouldn't I? Okay, so let's do that. So again, we have 2 characters. Then we'll take our end and we'll keep moving it. We'll keep moving it until we get to the end, or until our substring doesn't satisfy the criteria we were given. So then we'll bump it again, boop. And now we have this new window of ABC. Now in this case, K equals 2, so we have too many unique characters, right? So what you do to fix this is you then start moving your start until your criteria is satisfied again. So then we'll move S. And now we have this substring. Okay, now we only have BCB. Perfect. So this is our new substring. It's the same length as AB, so we don't really need to keep track of this one. It's not any longer. Okay, our criteria is satisfied again. Now we'll go ahead and move our end position. Boop, move our end position. Now we have a new substring. It's only got 2 unique characters in it, so we don't need to move our start position. We can leave our start where it's at, and now we have a new longest substring of BCB. So now we can save this as our new longest substring, and then we'll move our A again, or we'll move our end again. Now we're at the end. Let's look at our final substring we have. Okay, BCBA. This has got too many unique characters, so now that means we need to bump our start again. CBA, again, too many unique characters. Now we need to move our start again. Okay, so our last substring we get is BA, and this is shorter than the one we've already found, BCB, so we don't need to return this. Does that make sense? That's kind of this idea of a sliding window. You've got, you know, this little window here that just keeps sliding along until you get to the end. So I think that's what we want to do here. It's going to be pretty efficient. It's a linear runtime. You only have to go through the string one time. So let's write it out that way. So how are we going to do a sliding window with this? I think it's going to be almost exactly like we just wrote it, right? So we're going to first thing we want to do is probably break up our string into a char array. And that'll make it, I think we have to do that, right? Can we index a string? Maybe we can. Huh, okay, well. Maybe we don't have to break up into chars, right? And then what happens if we go out of bounds? We get no. Okay, well, it already works like an array, so I guess we don't need to do that. So let's instead create our start and our end. Ooh, we don't want to use end. That's a keyword, huh? Beginning. Start's fine. Start, finish. Okay, so that's going to be what we return. That's going to be our maximum substring. So we're going to do s dot, and what do we have for substring in Ruby? Do we have a substring that we can call? Undefined method substring. I think we might be able to just do this then, right? Yeah, that'll work. That will work just fine. So 0 dot dot blah. And just to make sure we can use variables in there as well. A equals 0, B equals 1. So we'll do sub of A to B. Perfect. So then the result that we're going to return is going to be our string from start to finish. Okay, now we just need to do the guts here. We need to figure out what our longest substring is. So what is that going to look like? Well, we need to create our window, right? So we'll do window start, window end, and those also are initialized to 0. And we want to continue until window end is less than, is greater than, while window end is less than string dot size. Right? So while the end of our window is still within our string, we'll walk through this loop. Now step 1, we need to keep track of our characters, right? So we'll do counts. We can do this in a hash. And then we'll take our first, so we'll take our substring of, oh, actually, no. So we'll take our character at our position of the end of the window. Yeah, okay, this is what we want to do. So we take our character here. We can add that to our hash. Right? I think that's what we want to do. Yes, yes, yes. And then so we take our count hash, we take the key of this character, we initialize it to 0 if it doesn't already have a value. And then we can add 1 to it. Right? I think that's what we want to do. Do we care about the count of each character? Does that actually matter? I don't think it does. I don't think it does, right? I don't think it does. Oh, yes, it does matter. Yes, it does matter. Sorry. Okay, so the reason we want to keep track of counts, right, is because of the way the sliding window works. So if we walk through if we get to this point here, we want to know we have 3 A's, because if we move the beginning of our window over 1, we need to know that we still have 2 A's. And then if we move it over 1, we need to know that we still have 1 A. And then if we move it over 1, we need to know we have 0 A's so we can remove it. Okay, So let's keep track of the counts for now. And then, so we've counted our characters. Now, if we have too many keys, right? So while counts, let's call this count. While count.keys .size is greater than k. So while we've got too many characters in our substring, this is where we're going to move our starting point. We need to take the count of this character and decrement it. If this is now 0, let me make sure that's actually something we have access to here. 0. Okay, excellent. If that count is now 0, then we want to completely remove it. So let me make sure we know how to remove a key. Okay, perfect. We want to delete that key. Count.delete. And then the beginning of our window goes up 1 position. All right. Perfect. I think that's what we want to do. So if we've got too many characters in our substring now, then we're going to move our start point over 1. But before we do that, we need to take the character that was at that point, decrement our count once, and then completely remove the key if it's now 0. And then we'll be counting our keys again to see how our substring is looking. Okay, so we've added the character of our endpoint. We've moved our beginning of our window over to the necessary point now. I think what's left to do is to see if we have a new longer substring. So if the end of our window minus the start of our window, remember these are indexes, is greater than the longest substring we found so far, then the new end of our substring is the end of our window, and the new beginning of our substring is the start of our window, right? And then we're going to want to move the end of our window up 1 point and keep doing this. Okay. There's got to be a mistake in here, which is what I always say before I run my code. I'm very self-conscious. But let's give it a shot. Oh my goodness. Okay. I'm gonna run it again. Cool. So it works. This is the sliding window. Let's add some more test cases just to make sure we haven't done something crazy in here. So what are some other substrings we can play with? I guess first off, let's increase k to 3. And we would expect that to give us this whole string. 1, 2, 3, 4, 5, right? So A, B, C, B, A. Let's run that. Okay, that worked. Let's set it to 1. And we would expect this just to be the first character. Okay. What other weird edge cases could we do? I mean, we could try k of 0 and an empty string, but what's the point in that? I mean, I guess we'll do it. Yeah. K of 0 and an empty string. This is going to just cause us to do like an early return somewhere or something. I don't know. We'll run it. Oh, well, I guess that works anyway. Okay, sweet. So I think we're good to go. Let's pull up our solution, make sure we don't need to clean it up at all. Yeah, I think this is good for now. 20 minutes? Yeah, plenty. All right, let's add this into a commit. Looks like we still got our readme to commit as well. So this is our problem. Good. We'll add this in a commit. Add exercise for today, which is the 14th. Ooh, happy Valentine's Day. And then here's our solution. Perfect. And then push that up. Okay, that's it for today. We'll see you again tomorrow. Thanks for joining. Bye.